Welcome to another GeoBoost video. We are in the Submodule 1.4, Ground Source Heat Pump Systems, Part 5, and I want to tell you something about geostructures. Geostructures are actually some construction components which are anywhere necessary, for example, for static reasons, for building or a platform or whatever. And then we put pipes into these geostructures, so into piles or whatever, and use that as a heat exchanger. So we know several specific designs of these heat exchangers in the piles. In general, you have a steel cage, for example, so a reinforcement cage, and put here the heat exchanger pipes directly on it, that you can use this pile as a heat exchanger in the underground. So here you see some constructions, how it looks like. So you have this reinforcement cage, and then you put just the pipes to the cage, and then you can use it as heat exchanger, as I explained before, and then to plug into the heat pump. You can use a lot of these piles here, as you see in the building in the middle, and then you can use it for heating and also for cooling. And for cooling, it is very important because for these geostructures, normally you need a recovery phase. This is very important because if you actually just use the heat of the underground, you cool down the underground, and the underground can easily freeze. And this can actually lead to frost damage at the piles. So, but if you have a good recovery phase during summertime, for example, you take the heat from the building and then inject it back to the piles, and so you recover the cold underground here, and then you can use it for heating in the wintertime again. But for this active thermal regeneration in the underground, you need a supply of a specific amount of extracted heat over the year. So the cooling phase during summertime should be included in the calculation and planning. Well, of course, this is especially the case if you do not have a high groundwater flux. If you have a high groundwater flux in the underground, this is very favorable for geostructures, because then actually the groundwater brings you a heat to the geostructures, to the piles, and you can recover the underground here. So this means that you need a low seasonal dependency, or you have a low seasonal dependency between heat extraction and supply, and also the higher thermal output rates are possible here. So, of course, you can use a lot of geostructures. You can use foundation piles, retaining walls, platforms, road de-icing, and also tunnel walls. All these is possible and is also used. So these are the geostructures, and at the end of this lecture, I want to show you a summary and also a comparison of the different systems, shallow geothermal systems I showed you. So we have ball heat exchangers, we have groundwater heat pumps, we have shallow collectors, and also geostructures. Of course, you can compare these by the different system types, so closed loop systems and open loop system. As open loop system, we have the groundwater heat pump. There is also the potential to cooling for every system, but groundwater has the highest potential, and all the others have also a good potential. And this is a big advantage of shallow geothermal in general, that you can heat and cool your building with these systems. Of course, sometimes you need a drilling, sometimes you need an aquifer. So for groundwater heat pumps, of course, it is essential that you have groundwater available, otherwise it's not possible. But for the others, you can do that in any case. Of course, you have to consider how deep you have to install your system. What is the installation costs are also quite very important. Of course, we have in the systems, we do not have to install them so deep. The installation costs in general are not so high. Of course, but the efficiency, it's the other way around, more or less. So the efficiency of groundwater heat pumps, for example, are quite high because you have a high uh, underground temperature here, what you use, but also ball heat exchangers has a good efficiency. The lowest efficiency have the shallow systems like the collectors. Of course, it is also dependent which space do you need for such systems, if you need a higher space or a lower space. And so coming to the main advantages of such in the comparison, so ball heat exchangers have can install everywhere. So there are just some restrictions about legal constraints. For example, water protection areas. This is maybe not possible, but then you have also constant performance, and you can upscale for different sizes and different building sizes. Of course, groundwater heat pumps has a high efficiency, and especially in free cooling, it's very favorable, and the installation costs are medium, but of course you need an aquifer somewhere. Shallow heat collectors has the lowest installation costs as an advantage, and geostructures can be integrated in many, many buildings, and there's no extra space demand, which is very good for geostructures. But coming to the disadvantages, it has a relatively low efficiency. This is also for shallow heat collectors, and as I said before, groundwater heat pumps need an aquifer, and all heat exchangers are relatively expensive compared to the others. So this is all for the ground source heat pumps, what I want to tell you, and hope to see you in one of the next videos.